Okay, so now we're in chapter 6. Thank you. Welcome back to you guys, too. So now we're in chapter 6. And we're going to talk about identities. So an identity is something that is always equal. Like if I say 4x equals 4x, well, that's an identity, right? They're always equal. It doesn't matter what x equals, it's always true. If I say 4x plus 1 equals 7, well, this is a conditional. This is an identity. This is a conditional equation. Right? Because this one is only true when x equals 3 halves. Is that right? 3 halves. 3. Yeah, 3 halves. So when x equals 3 halves, this is true. So that's why it's called a conditional equation. Does that make sense? Does everybody understand what I'm saying? Okay, very good. So we want to be able to see, so first thing we're going to do here is it says simplify by rewriting each trigonometric function in terms of sine and cosine. So we have tangent. Tangent's equal to sine over cosine, right? And the secant is equal to what? One over cosine. Good. So now, using algebra, I can say this is equal to the sine of theta over the cosine of theta times the cosine of theta over 1, right? And then I can cancel these, and I can say this is equal to the sine of theta. So I can say tangent of theta over secant of theta is equal to sine of theta. Always. It's an identity. Good? Okay, now it says the sine of theta over 1 plus cosine theta equals 1 minus cosine theta over sine theta. And it says multiply the numerator and denominator. So we're going to always work from left to right. Always work from left to right. So we say that the sine of theta over 1 plus cosine theta. And I'm going to multiply the numerator and the denominator by 1 over 1 minus cosine theta over 1 minus cosine theta, right? So now if I multiply, I get sine theta times 1 minus cosine theta over, what's 1 plus cosine theta times 1 minus cosine theta? Yeah, I think you have the right idea. You just wrote it wrong, Griffin. It's 1 minus cosine squared theta. Okay, yeah, I thought so. Now, here's that thing. We didn't go over that yet. Wait, hold on. Let me see something. I just want to see something because I'm looking for something in particular. Oh, I don't know where it is. We have to talk about it. Did I miss it? Did I miss it? Oh, I did. I missed this whole thing. This is a very important piece. Okay, sorry about that. So we're starting here. Hold that thought. So we know the reciprocal identities, right? And we know these. Is that correct? Well, don't worry about this. Basically, we know this and this. Don't worry about the middle one. That's silly. Okay. So now, here's what we have to talk about: is we have to talk about the Pythagorean identities. So let me make a new page here. So the Pythagorean identities. Basically, let's look at our triangle. So we have this triangle here, and I'll call this theta. And I know that x is the same as the cosine of theta, right? And I know that my y value is the same thing as the sine of theta. And I know that that's true if this is 1. Good? Okay. So I have an identity which says that using the Pythagorean theorem, that cosine squared theta plus sine squared theta has to equal 1, right? Okay, so this is a very important identity. You have got to know this. But it's not hard to know. It comes from there. Okay? Now we have a couple of other identities that go with it. Now, let's say I have this cosine squared theta plus sine squared theta equals 1. And I want to put it in terms of tangent. Well, I know the tangent is the sine over the cosine. So that means that to put it in terms of tangent, I have to divide everything by cosine. So now what I have is 1 plus tangent squared theta is equal to secant squared theta. Okay? Is everybody with me? Okay. And now I have one more. If I want to have something in terms of, what do you mean break it down? How do you want me to break it down? Ask me a better question. Do you have a microphone, Stacy? If you have a laptop, you have a microphone. Just hit talk. Well, what's cosine squared over cosine squared? You got the whole thing now? Okay. So now, let's say I start here with cosine squared theta plus sine squared theta equals 1. And let's put it in terms of cotangent. So cotangent is cosine over sine. That means I have to have sine squared theta in the denominator, right? So I'm just multiplying through by, or dividing everything, both sides by sine squared theta. So here I get cotangent squared theta plus 1 is equal to cosecant squared theta. So there's another identity. So these are actually my 3 Pythagorean identities. I don't know why I can't get that to stay. So those are my 3 Pythagorean identities. I would just memorize this one because it makes the most sense, right? like people can understand where it comes from. And then if you need tangents, well, just divide by cosine. If you need cotangents, divide by sine. If you need cosecants, you know what I'm saying? Don't try to memorize all of this. It's too much. Yeah, of course. So that takes care of, hold on. So that takes care of these Pythagorean identities. So really all we have to do is worry about one of them, right? Now the last one is our symmetries. So how do I do symmetries? Well, does everybody remember back in the old pre-calc days when we talk about odd and even functions? Actually, we talked about this already when we talked about graphs, right? So odd functions are f of minus x is equal to minus f of x. And our even function is f of minus x is equal to f of x, right? And we also knew when we had odd functions, such as x cubed, it's symmetric about what? Good. X cubed is symmetric about the origin, so odd functions are symmetric around the origin. Good. And even functions are symmetric where? Y-axis. Very good. So this is our review of odd and even functions. Now let's look at sine, cosine, tangent. So the sine function looks like this, right? Cosine basically looks like this. And tangent kind of looks like this, right? So if this is the sine, is the sine odd or even? The sine is odd, exactly. So the sine is odd. The cosine is even. Good. Tangent is odd. Got it? Does anybody not have this? Math is amazing, right? So let's see. There we have our symmetries. So because the sign is odd, f of minus x is equal to minus f of x. Cosine f of minus x is even, so cosine of minus x theta is equal to the cosine theta, right? Okay, so this is, so there we have our odd and even. Right? Tangent? Yeah, no problem. Okay, we're all good? So now we understand all of these trig identities. So let's see. Now let's go back to where we were.